Detailed comparison. Jetson Nano versus Arduino versus Raspberry Pi. When deciding between the Jetson Nano, Arduino, and Raspberry Pi, it's important to understand their capabilities, limitations, and the types of projects they excel in. Below is an in-depth analysis of each platform. 1. Jetson Nano. The Jetson Nano, developed by Nvidia, is a high-performance computing device designed specifically for AI, deep learning, and robotics projects. Key features: processor, quad-core ARM Cortex-A57 CPU with a 128-core Maxwell GPU. RAM, 4GB LPDDR4 memory, essential for running AI and machine learning applications. Storage, SD card slot for storage, external SSDs are supported. Operating system, Linux-based, typically using the Nvidia Jetpack SDK, which includes AI tools like TensorFlow and PyTorch. Strengths, AI ML capabilities, optimized for AI and machine learning with support for CUDA, TensorRT, and deep learning frameworks. High-performance GPU, excellent for image recognition, object detection, and real-time video processing. Edge AI, ideal for real-time decision-making tasks in robotics and IoT systems. Weaknesses: power consumption, higher power usage 5 to 10 watt, requiring more robust power solutions. Cost: more expensive than Arduino and Raspberry Pi. Complexity: steeper learning curve, especially for beginners unfamiliar with AI frameworks. Best applications: robotics with vision-based navigation, object detection, facial recognition, and video analytics, AI-powered drones or autonomous vehicles. Arduino. Arduino is a microcontroller platform renowned for its simplicity and effectiveness in hardware interfacing and automation. Key features: processor, typically an 8-bit microcontroller like the ATmega 328P found in Arduino Uno. Memory, limited, e.g. 2KB SRAM, 32KB flash memory in Arduino Uno. Operating system, none. Code runs directly on the microcontroller. Power, very low power consumption, can be powered by batteries or USB. Ease of use, beginner-friendly, with a straightforward programming language, C++, and an extensive library ecosystem. Low power, highly energy efficient, suitable for battery-operated projects. Hardware control, exceptional at interfacing with sensors, motors, and LEDs. Modularity, compatible with a wide range of shields for extended functionality, such as Wi-Fi, Bluetooth, or GPS. Weaknesses: limited processing power, not suitable for tasks requiring significant computational resources or multitasking. No operating system, cannot run complex software or GUIs. Small memory, insufficient for applications involving heavy data processing. Best applications: simple IoT devices, e.g. temperature sensors, motion detectors. Home automation systems, robotics control, e.g. motor control, signal processing. Educational projects in electronics and programming. 3. Raspberry Pi. The Raspberry Pi is a credit card-sized computer capable of running a full operating system. It strikes a balance between versatility, affordability, and ease of use. Key features: processor, varies by model, e.g. Raspberry Pi 4 features a quad-core ARM Cortex-A72 CPU. RAM, options ranging from 2GB to 8GB in Raspberry Pi 4 models. Operating system, Linux-based, Raspberry Pi OS by default, but supports Ubuntu, Windows IoT Core, and others. Connectivity, built-in Ethernet, Wi-Fi, and Bluetooth on most models. Strengths: full-fledged computer, can run Linux, Python, and other programming environments, making it ideal for general-purpose computing. Affordable, reasonably priced for its capabilities, offering excellent value. Versatile, useful for education, media servers, IoT, and even light AI/ML tasks. Active community, extensive support and a wealth of online resources. Weaknesses: limited GPU power, not optimized for heavy AI or deep learning tasks. Moderate power consumption, uses more power than Arduino but less than Jetson Nano. Not as robust for hardware control. While capable, it's less straightforward than Arduino for interfacing directly with hardware components. Best applications: media servers, e.g. Kodi. Education, learning programming and Linux. Home automation systems, lightweight AI projects, e.g. speech recognition, basic object detection. Prototyping IoT solutions, comparison by application. AI/ML and robotics, choose Jetson Nano for projects requiring advanced AI computations or GPU-intensive tasks. Raspberry Pi can handle lightweight AI tasks, but struggles with large models or real-time inference. Arduino is not suitable for AI/ML as it lacks the computational power. Hardware interfacing. Arduino is the best option for projects that need precise control of sensors, motors, or other hardware. Raspberry Pi can manage hardware interfaces, but isn't as intuitive or low-level as Arduino. Jetson Nano can interface with hardware, but is overpowered and complex for basic control tasks. IoT and prototyping. Arduino is ideal for simple, low-power IoT devices. Raspberry Pi excels in IoT applications requiring connectivity and moderate computational power. Jetson Nano is suitable for IoT applications involving AI, like smart surveillance. Education and beginners. Arduino is perfect for teaching electronics and programming fundamentals. Raspberry Pi is better for learning Linux, Python, and general computing. Jetson Nano is challenging for beginners unless they have prior experience in programming or AI. Conclusion. Use Jetson Nano for cutting-edge AI, ML, and robotics projects requiring GPU power. Use Arduino for low-cost, low-power hardware control and simple IoT devices. Use Raspberry Pi for versatile, affordable computing, education, and moderately complex projects. Each platform shines in its domain, and the best choice depends on your project's goals, budget, and technical requirements.